The third automated ABR algorithms we want to talk about is called ALGO. It took me a while to figure out what does ALGO stand for. It ends up because it's quite easy. ALGO is simply the first four letters of the word algorithm. Wow, funny. So it's basically an algorithm, the first characters of the word algorithm. ALGO is designed for hearing screening purposes. It's just for screening. It's not for diagnostic. So that means you primarily are dealing with newborns or young infants. As such, you want to be careful on the headphones you use. You likely will use circumaural headphones for children or young infants. And for newborns and very young infants, you probably will use specialized ear cup. And when you are purchasing the ALGO hearing screening systems, they usually will come with specific cups with foam cushion to minimize collapse of external ear canal. Because when you are doing the hearing screening, you don't want to do anything that would collapse the external ear canal. So one important way to avoid that is to use supraoral headphones or a specially designed ear cup, and that you can simply attach onto the ear. And also those specialized ear cups, they almost always have foam cushions, and that will minimize the collapse of external ear canal. The clicks usually are presented as 35 dB NHL. And again, the clicks intensity is specified by the ALGO machine itself, by the company. And in some versions of the ALGO systems, produced by certain manufacturers, you can specify different clicks intensities. However, in most systems, it's just one fixed intensity, and usually it's 35 dB NHL. And the way it works is actually very easy and simple. We basically compare our averaged time waveform from a newborn to a template ABR waveform that is obtained from the average of a group of normal newborns. So essentially, we compare the ABR waveform recorded from a specific newborn or patient and compare that to a template. And a template is established by recruiting a group of norm people. So if you are doing ALGO on newborn, you would use the template obtained from newborns. If you do it on, say, 1 month old infants, you will use a template that is obtained from 1 month old infants, and so on and so forth. So in other words, the recorded averaged waveform is compared to age-appropriate template. So this figure shows some drawings to illustrate how ALGO works. It's actually very easy and straightforward. On top is a template obtained from the same age group for your participant, and this template basically shows is the averaged ABR waveform obtained from the same age group of your patient. And let's say we get an ABR waveform that looks like this. Whatever age group it is, they say the ABR waveform looks like this. And then here is the EEG, the averaged time waveform from a specific patient. They say a newborn or an infant or children, just a recording for a patient, and apparently use the template from the same age group for your patient. And they say this is the average waveform you recorded from your patient, from a specific patient. And ALGO simply do one thing, just do a cross correlation between the two waveforms. So what do you mean cross correlation? Basically means when the template goes up, is the recording goes up. When the template goes down, is the recording goes down. So that is basically the basic question. So if the template goes up by this amount, and the recording also goes up by a similar amount. Similarly, if the template goes down by similar amount, and the recording also goes down by comparable amount, then in that case there will be a very good cross correlation coefficient. And on the other hand, if the recording amplitude fluctuation is not correlated with the template, then there's no response. So in other words, if we have a good cross correlation between a recording and a template, then there is a response. On the other hand, if we have a poor cross correlation between the recording and the template, then there's no response. So ALGO is as simple as that. So this is another slide showing the similar ideas for ALGO. It's a response detection algorithm. So at the bottom is the recording from an actual participant, and on the top are the template. So on the template, we expect to see up and up and up and down and down and down and down, and then up and up on these different locations. Then in the actual recording, we would expect to see similar amplitude variations. And again, it's a cross correlation. If we get a good cross correlation between the recording and the template, then there's a response. On the other hand, if we get a poor cross correlation, then there's no response. When using ALGO to do hearing screening, we must make sure to use an appropriate template for the same age group and disorder for the participant. Otherwise, ALGO will not work. This is the reason that you must enter the patient's date of birth into ALGO when conducting hearing screening, so that the ALGO knows the age for the participant and will use the appropriate age group template for algorithm. Another example is if you have a newborn who is born with Down syndrome. This Down syndrome newborn will fail ALGO because ALGO template is based on normal hearing newborns. Even this Down syndrome newborn has normal hearing. This Down syndrome newborn will fail ALGO because the Down syndrome newborn have their different ABR waveform and template. Additionally, if I, Dr. Gent, underwent ALGO, I will fail ALGO because ALGO has no template for elderly people. And again, when you use ALGO, you must make sure that you are using the same age group and disorder. I mean, this mostly is done internally within the commercial software. When you enter the participant's date of birth, ALGO knows the age of the participant and will use an appropriate template for that. This slide shows the advantages and disadvantages of ALGO. For the advantages, first, it's fast. It's really fast because once you have a correlation that goes beyond a preset criterion, then you can stop recording. The patient passed the screening. It is well studied, and the correlation with conventional ABR ranged from 83 to 98%, which is really good. And ALGO also have very good sensitivity and specificity. And also, ALGO can identify patients with auditory neuropathy. On the other hand, if you use OAE as hearing screening, OAEs cannot identify patients with auditory neuropathy. So in other words, if you have a patient with auditory neuropathy, those patients will fail ALGO, so that we know something is wrong with them, including patients with auditory neuropathy. Okay. And ALGO is very easy to use. It can be done by nurses, technicians, and people with some basic training. The overall referral rate for ALGO is much lower than using OAEs. This is not a good thing. You don't want to over-refer too many newborns, or otherwise all the parents will get get so frustrated and worried. The disadvantages of ALGO include that the supplies are expensive because you have to use specialized phone cup, and you have to use recording electrodes that are disposable. And those supplies, consumable supplies, are quite expensive. It's about $5 to $10 for each screening. And also, when you use ALGO, you may miss mild hearing loss. Also, you may miss unusual autometric configurations. That is because click AVRs is good only to predict 2 to 4,000 Hz region only. So again and again, when we use click evoked AVRs, do not overinterpret the results. It only correlates with 2 to 4,000 Hz range only. So these are the disadvantages of using ALGO. So in terms of the pros and cons listed here, you be the boss, because pretty soon you will graduate and have your license, have your own clinic. Then whether you want to use ALGO ABR for screening or you want to use OAE for screening, it's up to you. So this slide shows the comparisons for hearing screening by using ABRs versus OAEs. So for ABRs, it's plotted by the dark red line or purple line here. So the acoustic sound comes in, goes through the external ear, middle ear, cochlea, inner ear, and auditory nerve up to the brainstem area. So ABR is a screening for neurosynchrony of the auditory pathway link. And however, is able to detect auditory neuropathy. However, ABR will miss spatial audiometric configurations, and ABR is only good for 2 to 4,000 Hz range only. On the other hand, for OAEs, it goes to the external ear, middle ear, and part of the inner ear. So OAEs are frequency-specific screening of the cochlea and middle ear. So you get frequency-specific information. For that, then you can detect different audiometric configurations because you have frequency specificity. However, you will miss patients with auditory neuropathy because OAE is only screens for outer hair cell status. It has nothing to do with neurons and auditory and neurosynchrony. So the ABR and OAE for hearing screening, they have pros and cons for each. So at the end, it really is up to you on which method you want to use for hearing screening in your clinic.